Hi, grade fives. Today we are going to be looking at quadrilaterals. I'm so excited.
Okay, so for today's lesson, we are going to be looking at different quadrilaterals and what defines them as being different from each other. So our first one that we have is a square, and we know that something is a square when all four sides are equal. And remember how we showed that its sides are equal. We put these hatch marks on here. And then also these have to be 90-degree angles. Now, if you were to look at this also as cutting these, the diagonal angles are perpendicular to each other, meaning that these are 90 degrees also in the center. Now, a rectangle, we know that the difference between a square and a rectangle is that not all sides are equal in a rectangle. These two sides are equal to each other, and these two sides are equal to each other, but not all of them are equal. That is the main difference between the square and the rectangle. These are all 90-degree angles as well. That's the difference between the rectangle and the square, and the rhombus and the parallelogram as well. And when you cut these and make them diagonal, looking at the angles and cutting it through, these are equal to each other and these sides are equal to each other as well. Now for the rhombus, all sides are equal on a rhombus, which is similar to your square. However, the angles are not the same, right? Because it feels like it's almost we take a square and we bend it a little. That's the difference between the rhombus and the square. However, when you do actually make a diagonal line through this, these are actually perpendicular to each other in the center. Now, the parallelogram is like doing that same bend, but with a rectangle. So not all sides are equal on a parallelogram compared to the rhombus. These two sides are equal, and these two sides are equal. But because it's bent a little, meaning this angle isn't equal to this angle, it doesn't have the same as a rhombus when it comes to those sides being equal to each other. Then we have the trapezoid. Now the trapezoid has two parallel lines, but the other two lines are not parallel to each other. They're actually going in towards each other, or if it's the other way around, out towards each other when we're looking at a trapezoid. And then you have the kite. The kite has two lines that are equal to each other and two other lines that are equal to each other, but you have one angle that goes in towards the actual shape itself, and that's the big difference between the kite compared to the rest of them. Now many of these also, when you look at the rectangle, square, rhombus, parallelogram, have parallel lines as well. These two are parallel to each other. These two are parallel to each other. Same with the square. Same with the rhombus, that these two lines are parallel and these ones are parallel to each other. So that's what makes all of these quadrilaterals just a bit different from one another. Knowing that the rhombus has similarities to the square, except for the fact that it's just kind of bent. It doesn't have those 90-degree angles. And a parallelogram, similar to a rectangle, only it's bent just the same as the rhombus. So the rhombus has similarities to a parallelogram and similarities to the square. And the trapezoid has the similarities of having two parallel lines, but the other two are not parallel to each other. They could be equal to one another, just the same as this one, but some trapezoids aren't. So for the next part, I've taken a picture, and I suggest that you pause the video and take notes from the picture. So another thing that we can look at when it comes to quadrilaterals and the attributes of them is the line of symmetry. Now, a line of symmetry basically means to divide the shape into two congruent parts. Now, the word congruent means exactly the same. As you can see on my trapezoid here, when I make a line of symmetry going down the center of it, I have two sides that if you fold them in on each other are exactly the same. That makes these two sides congruent to each other. Now, for a trapezoid, there is only one line of symmetry. For something like a rhombus, we have, if we were to divide down here, we have one line of symmetry that way, these two sides being congruent. We can also go right along these two angles, making these two sides congruent to each other. Now, for a square, you actually have 4 lines of symmetry. So you can take a square down the middle like this, making these two sides equal. You can also do it horizontally, making a line of symmetry this way, making these two sides equal. You can also make a line of symmetry throughout the diagonal part with these two angles, making these two sides congruent, and then coming down this way, making these two sides congruent. So there's actually 4 lines of symmetry for a square. Oops. And I can write 1 line of symmetry for a trapezoid, and then 2 lines of symmetry for a rhombus. For the parallelogram, there is actually no line of symmetry for it. I can't split it down this way and fold it onto each other because this side is longer than this side. The same that comes here if I was to do it this way and try to fold this one, this corner right here would come over here. So it wouldn't be exactly mirror-like to each other. The same approaches for doing diagonal, that if I was to fold this onto one another, it wouldn't be congruent. It wouldn't actually match. So for a parallelogram, there's no line of symmetry. And for any shape that is a quadrilateral, meaning it has 4 sides, if the sides are not equal to each other and the angles aren't equal to each other, you're definitely not going to find any line of symmetry for something like this shape. So this one has no line of symmetry either.